Okay, I think we can start today's session. Okay, just a second. Okay, so today we are actually continuing with the topics that we have not covered in the last week. Basically, I have shown you some simulation of a very basic robotic arm, like a two-door robotic arm. So we will discuss about that today, and also in the R2D2 robot we have seen a thing called plugins, right? Gazebo plugins. So that I will give an idea about that as well. Okay, so we will start with the Gazebo plugins, then we will be going to the robotic arm. Okay, so I hope you remember the R2D2 simulation. So first, let me just give an abstract of what is Gazebo plugins. Okay, Gazebo ROS plugins in specific. So let me take the workspace, and so the RR board sim tutorial, and I think you are aware of the sacro file, that is the 30 diff drive. This is a complete sacro file with all the all the transmission tag, then the Gazebo ROS control plugin, and almost all the things I think we have added. And in this robot we have seen about the controllers, right? Diff drive controllers, right? So the diff drive controller is actually will work with Gazebo and also in real robot. So if you want to interface a real differential drive robot, you can able to do that, okay, using this plugin. I mean, it's not a plugin, it's a controller. So you have to be careful about these two terminologies, a controller and a Gazebo ROS plugin. Okay, so a controller is what a separate entity which is not depend or which is actually applicable for simulation and for the real robot. Okay, but a Gazebo ROS plugin is what which is specific for the simulation. Okay, it's actually a plugin of Gazebo Simulator. Okay, and why I mentioned this, because you can able to do the differential drive using Gazebo plugin as well, Gazebo ROS plugin as well. Okay, so let me show you an example. Okay, so if you just take the browser, and if you just search about Gazebo ROS differential drive or something like that, you will get Gazebo plugins, and also if you check the yeah if you check this repository, this is a main repository for Gazebo ROS plugin. Okay, so in my previous lectures I mentioned that the Gazebo functionality can be expanded by writing plugins, Gazebo plugins. So here what we are doing is we are writing Gazebo ROS plugins, meaning these plugins can act as a bridge between Gazebo and ROS. For example, a Gazebo ROS plugin of a laser scanner. Okay, if you add a laser scan of Gazebo ROS plugin, then that plugin will publish the laser scan data in a topic. Okay, the output, I mean, the plugin will read the actual laser scan from the simulated environment, and then it will be publishing that in a topic. Okay, so basically we are loading a Gazebo plugin, but that is actually publishing the ROS topic of the laser scan. Okay, so all these Gazebo ROS plugins are available here, and I mentioned about the differential drive, right? So for the differential drive robot as well, if you just go down, maybe I can share this link. Okay, if you just go down, you can see differential drive. Okay, so if you want to simulate the robot, okay, only simulate the robot, then you can use this plugin in the URDF, okay, or in the URDF or Sacro. If you add this plugin, and if you just mention what is the left joint, right joint, then the wheel separation, all this stuff, then the robot in the simulation will work in the differential drive manner. Okay, and if the robot is having 4 wheels, then you can use another plugin called skid steering drive. So these plugins, all the plugins are available, already installed on your system. When you install ROS, all these things are installed. So very important point, this is only applicable for the Gazebo simulation. Okay, so the advantage of using the controller is that the controller can be used in hardware and the simulation. Okay, so you can use the Gazebo plugin or the controller. Okay, both are possible, and we will see the examples of simulations with the Gazebo ROS plugin and with the controller. Okay, so just have a look on to the Gazebo ROS packages, which will install when you install ROS, and you can see Gazebo plugins, and if you check the source code or header file, you can see a list of plugins that is already available. Okay, so if you want to add a camera and a camera sensor into the simulation, we have Gazebo ROS camera plugin. Okay, so the tutorial for the camera is actually here. If you just search about, yeah, I think just add this section. Yeah, so this is a plugin that we are using for the camera, RGB camera. So the plugin actually needs the link that is attached. I mean, in a robot, there should be a link for the camera. Okay, so here in the robot there is a link called camera link, and this plugin is attached to that link. Okay, so whenever that link moves, this camera will also move. Okay, so this example we will see in the RR board as well. Okay, so you can simply copy paste this section, just change this link Gazebo reference. Gazebo reference means this simulation is referring to this link. Okay, okay, all the other stuff you can change. Okay, this is the important point. So yeah, so you can add camera, and you can add depth camera. Okay, not only normal camera, depth camera, then this is what I mentioned, diff drive. So all this camera I mean camera tutorial or differential drive, all these things are mentioned in this link. I think I have shared it. Okay, so if you are specifically looking for simulation plugins that can interact with ROS, these are the list of plugins. There are many plugins. ROS laser is there, ROS multi-camera. If you want to implement stereo cam or something, there is multi-camera, then projector. I mean, there are many plugins, and you can also write your own plugin. Okay, that is the ROS template. So there is a template for creating a Gazebo ROS plugin. So you can simply create a new one. Okay, so the list is not I mean limited. I mean, these are the official Gazebo ROS plugins, but there are third-party plugins as well, so you can use that. Okay, so it will be in a form of package, ROS package, so you can simply clone it in your workspace and build it and add that plugin definition. Okay, yes, so that is the idea of Gazebo ROS plugins. Okay, I mean, an abstract idea, but when we discuss the example, you will get a clarity. So we are coming back to the RR board. Okay, so here you can distinguish between the controllers and the Gazebo plugin. So in this example, RR board is basically a robotic arm, right? So maybe I can simply show you the simulation. So just want to, like, maybe I can check ROS launch, RR board, control, then yeah, RR board control. Okay, I think I have included the packages in our repository. Okay, so yes, it is loading. Okay, so this is the RR board simulation, guys. So it is a two-door arm which is having a laser mounted on the end effector. End effector means the gripper part of the arm, and there is a box here, right? This is actually a link, okay, and this laser is also a link. So how many links are there? 1, 2, 3, 4, 5 links. And how many joints? There are on the bottom there is a fixed joint, okay, with the world is the root frame. So root frame, there is a fixed joint, and this is actually revolute joint, but they for the demonstration they are providing is a continuous joint. So 2 continuous joint, and then on the top these 2 sensors, no, these 2 sensors are fixed, okay, fixed on this link. Okay, so this is a simulation, and we can discuss how to attach these sensors. And so you know, like, these are sensors I mentioned, right? So if you add a sensor, then what is the output? Maybe I can simply show you that. So if I add an obstacle, okay, you can visualize that obstacle here. Okay, the purpose of the laser scan is basically finding the obstacle. So here you can see a series of points, right? So this is actually detecting this obstacle. Okay, and also there is a camera, okay, camera on the, I think on the top. Okay, so that is also visualizing here. Okay, so let's see the RR board description package, which is having the URDF, then the Gazebo ROS plugin, okay, and in the RR board control package, which is having the controller definition. Okay, so we have seen different types of controllers, right? So it is having the controller definition. So let's see the RR board description. Okay, so I'm just going to the URDF. So the sacro files are here. The main sacro is here. Now if you open it, you can able to see it is including different sacro files. So in this sacro file you can see the links and joints of the robot. So there is a parent frame, that is a world frame, that is a parent frame. You can decide, okay, you can name it the standard definition, standard I mean we are using world as a standard name. Okay, world is a parent, and the fixed frame, okay, the link 1 is actually fixed to the world. Okay, so yeah, then the link 1 is connected to link 2 through a join called join 1. Then the join 2, link 2 and link 3 is connected, that is continuous. And then the link 3 is actually the top link, yes. And there is a Hokoyo join, which is a laser scan. Name of the laser scan is Hokoyo, which is a fixed link, I mean fixed join. And there is a laser scan link, which is actually a mesh file. Okay, the link is actually represented by a mesh file. Then the camera joint is fixed, the laser scan is also fixed. Okay, so all these stuffs are there, and then we can go to the Gazebo plugin, Sacro, all these things. Okay, so this is the basic Sacro definition of links and joint. Addition to that, we need to load the Gazebo plugins. So what is the purpose of loading Gazebo plugins? In the simulation, you have seen the camera and laser, right? So that is actually achieving by adding the Gazebo plugins. So here, if you check Gazebo plugin.sacro, you can able to see we have added the plugins here. Okay, Hokoyo plugin. So this sensor is attached to the Hokoyo link, and then the plugin name is Gazebo libgazebo ROS laser. Okay, so that is the plugin name, and this is the topic name. Okay, topic name, and this is a camera plugin. The name of the camera plugin is called Gazebo ROS camera. Okay, so it's already there. Okay, you don't need to worry about, just copy paste. Okay, and you can give the name of the camera and also the topic name. Okay, you can give the topic name in which it's want to publish the camera images. Okay, yeah. Okay, so these are the Gazebo ROS plugin, and you know these things, right? These things is the Gazebo ROS control thing, because in order to interface the joints to a controller, we need to define a transmission. Okay, we need to define the transmission tag, and then we need to like load the controllers. Okay, so here in this example, in RR board example, we can see both the side, like we are using Gazebo ROS plugins for simulating the sensors, and also in order to control the joint 1 and joint 2, which is a continuous joint, we are attaching controllers. Okay, so this is basically the RR board dot sacro. Okay, so all these things are like Gazebo properties and all, like it's simply mentioning the color of the link. So when you simulate this robot in Gazebo, it is mentioning what color should the link have. I mean, just changing the color of the links during simulation. Okay, so yeah, so this is the abstract of the RR board description. So we have seen the Gazebo ROS plugin, and in order to use the Gazebo ROS plugin, the easiest method is like taking an example. Okay, there is no much changes. Basically, mention the reference link. Okay, meaning the link of the laser scan. Okay, so if you want to make a link as laser scan, just mention the name. Then these all things are same. You can change the name of the laser scan, and if you want to visualize the laser scan in Gazebo, you can make it true. Then update rate, samples, these all can change. Okay, this is for a 360 degree LiDAR, but you can change it. Okay, then you can change all the sensor configuration. It's all adjustable, and you can even add noises. Okay, because in simulation, you know, it is actually giving the ideal values. Okay, but in order to replicate the actual robot or actual LiDAR data, I think you can add noises. Okay, and this is a topic name in which the laser scan is getting published. Okay, and this is also for the camera. You know, the resolution of the camera, then noise need to be added, all these things. Okay, so if you are not aware of the camera parameters, just put the default value. Okay, And next I'm going to the RR board control. So in the control package, you know, we are configuring the controllers, right? We need two controllers, two continuous joins. So we are assigning some controllers, and also we need the robot, joint state controller. That is, I think it is loaded already. Okay, so here you can see we are starting the Gazebo simulation, then we are loading the controller configuration, then we are starting the two controllers. Okay, controller configuration is in the config folder, and then we are loading the controllers. Then this is for robot state publisher, and this is adding starting the ROS. Okay, so here they are not using the joint state control. They are actually using the joint state Gazebo plugin. If you just check, this is a Gazebo plugin for publishing the joint state. So that is also possible. So if you want to publish the joint state of the robot in simulation, you can either use a Gazebo plugin or a controller. Okay, so don't confuse with these terms. Okay, so let's see the config file, rrboard control.yml. So it is having the joint state position control, for join 1 and join 2, but they are not actually using the joint state control. We don't need to use it. Okay, it is actually using, the joint state is already publishing by let's see, it is publishing by this plugin. Okay, so I think you don't require this. So these two things you can see there, we are configuring join 1 and join 2 as effort controller, joint position controller. And then what we will get is, if you start the simulation, you will get the topics for controlling the joints. Okay, so here it is. So we can simply check the ROS topic list. So you can see we are getting what, these topics, all these topics are from the camera. Okay, simulated camera. And this is for the join position, join 1 control, and this is for join 2 control, and this is for laser scan. Okay, so I think you got an understanding about each topics, right? So what I'm doing is I'm just controlling the join first. So so we are using a plugin called EZ plugin. I think I have mentioned the installation of this plugin in the last lecture. So basically the EC message publisher, which is a plugin of RQT, what it does is that you can select a topic, and that topic you can easily publish the value using, if it is a integer like int32 or float, you can easily publish using a slider. Okay, so this is for the join 1. Okay, you can see while moving the join 1, you can see the laser scan is also moving. Okay, the same case for join 2. Okay, join 2, you can see. Okay, so these joins are controlling by the ROS controllers. Okay, and the sensors are simulated by the Gazebo ROS plugins. Okay, so sometime we will also call this plugin as controllers, Gazebo ROS controllers, but usually the common convention is Gazebo ROS plugins. Okay, So you can see the arm is moving. And at the same time, if you check the visualization, let me add some obstacle around this robot. So I'm just adding this, and let me see. Okay, I'm adding an obstacle. So if it is an obstacle, you can see it is blocking the laser scan. Okay, so laser scan, now how it is working is like the laser scan is sending the laser in 360 degree. Okay, but it will only return if there is an obstacle. Okay, so the laser scan will be returned, then only it will be giving the data to the user. So for example, if there is two obstacle, then in ROS you can able to find the laser scan. Just a second, just change to, yeah. Okay, so here you can see a line, right? Okay, just a sec. Let me change to points. Okay, this will be fine. Yeah, so here you can see there are two obstacles, right, here and here. So that is obstacle that we have added. And what is this? See, the laser is actually in an inclined I mean it's in an angle, right? So it is detecting the ground as the obstacle. Okay, the ground as the obstacle. So if you just visualize it on side by side, just a second. Oh, ROS is just crashed. Just a second. This is one problem that we are using VirtualBox or VMware sometimes because of the lack of yeah, it's actually shut down because of the lack of graphics. I mean, if you're working with the actual PC, it will be very smooth, but I'm currently working from the VMware. Okay, just a sec. Okay, let me just put it in side by side. Okay, I think this will work. Okay, oh, it's again, I think, yeah, it's stuck. Just a second. Yeah, I think it's not responding, guys. Just a second. Oh, yeah, let me just reboot the VMware. The thing is that what I'm trying to communicate is that like the laser scanner will detect the obstacle and view that 3D data in the 3D viewport, and the camera. So in order to visualize laser scanner in ROS, you have to add a laser scan display type. Okay, then mention the topic name. For the camera, similar, like there is an image display type, you can add it and give the topic name. Okay, so let me try to reboot. Sometime it will work. Or just try to shut it down. Yeah, I think the shutdown is working. Okay, great. Yeah, I'm taking it again. Okay, so yeah, so that is what we got it from the RR board simulation. So basically we have seen the controllers, we have seen the Gazebo plugins, okay, Gazebo ROS plugins, and we have seen a list of Gazebo ROS plugins. This is a tutorial for adding a Gazebo ROS plugin. So if you want to add differential drive controller, you can add in Gazebo, then sensors, camera. So then they are also mentioning the RR board simulation here. Multi-camera, so if you want to simulate stereo cam, that is possible. Then laser, yeah, laser scan, we have seen the example. Then force feedback, IMU, then yeah, I mean, there are a lot of sensors. Okay, so now we can jump into the next one. So before that, I just want to hear from you, like if you have any question regarding the RR board, let me know. After that, we can see different robot simulation. Like we will set up different simulation. Currently, I think I don't have, but I will try to set up some simulation like Husky, Turtleboard 3, exam, some examples. Okay, so let me know if you have any questions. Question related to RR board. And adding Gazebo plugins, then the controllers. So let me know if you have any question, guys. Any questions? Let me know. Like I know there is some confusion because you have seen controllers, Gazebo plugins, and but I will say, like, just go through these examples, then only you can understand the things. Okay. Okay, so if you don't have any confusion, then we can.
Sir, one
Yeah,
doubt.
yeah, yeah.
If we have a new sensor, can we have this plugin, or we need to define like
Yeah,
that?
yeah. So I can answer that. It's actually a relevant question. So that's what I mentioned. The thing is that in Gazebo we are simulating it, right? So yeah, if we get a new sensor, then just check if there is any Gazebo plugin for that sensor. For example, in this list there is no lidar. I think you have heard about the Velodyne lidar, right? It's a very popular lidar. So, but that is not available in the official website, right? So just check Velodyne Gazebo ROS plugin. Okay, then you will get Velodyne Gazebo ROS plugin. Okay, so most of the popular sensors, for most of the popular sensor, the Gazebo plugins are available. Okay, so the Velodyne, the plugin is available, but if you are having a I mean very rare sensor, then the only solution is writing your own plugin. Okay, so if you just go down, you can see, I think I have mentioned that there is a thing called template. Okay, so if you just go to the Gazebo ROS template, you can find a template of a plugin. Okay, so using this plugin, using this template, there is a ROS template.h, and also there is a Gazebo ROS template.cpp. Just a second. Yeah. Okay, so you have to create a package. Okay, and then you have to include these src and .h file. Okay, and you have to include the necessary necessary um, dependency. Okay, so in order to build it, so mainly the dependencies are like Gazebo dev and all these things. I mean, not everything, but it depends on the sensor that you are building. Okay, and then you have to compile it. Okay, you have to compile it. I mean, you will get the Gazebo ROS template, Gazebo ROS template. I mean, you will get some repository only with that. Okay, so you can simply follow that and add this sensor configuration. It's not easy actually. It's actually somewhat difficult, and there are some examples like Simple World plugin like this. So it's not easy. Okay, but try to find the sensor plugin. But if it is not at all available, then you have to write your own. Is that clear, Hari?
Yes,
Okay,
yes.
okay, okay. Any more doubts? Okay, okay. So now I think we can switch to some list of simulations of some popular robots. So I'm planning to show you first the Husky robot, Gazebo. So I'm simply googling it, and I'm finding some material of Husky Gazebo. So popular convention is that, like, in order to find the Gazebo package, or like Gazebo package means it will have robot description, then simulation things, controllers, if any, everything related to simulation. So just search with like Turtleboard Gazebo or Turtleboard Gazebo Simulation, something like that. Then you will get some material. Okay. So here, I think for Husky, for simulation, first thing you have to do is, I think you have installed the Synaptic Package Manager. So Synaptic Package Manager is having the list of ROS packages, official ROS packages, meaning the packages that is already available as binary. So you don't need to build the packages. Okay, so there are two types of installation of ROS packages. One is if you want to like install some ROS package, just check in Synaptic. So I'm just searching for Husky, and then search for like so you can see there are some Husky packages available. Okay, so this way you can install this package quickly without cloning these packages into your workspace and building it. Okay, so you can simply like just install it. Let's see whether it's work or not. I don't know really, because they didn't added it. I think it's a new one. So let me just click this package. I mean, click and install these packages. Okay. So before that, I just want to reload it. So reload means it will be fetching all the packages from the ROS server. Okay, ROS package server. So let me see. It will take a few seconds. Just a second. Okay. So after that we can install it. Otherwise, the method is that you will get the GitHub repository of Husky. So these are the list of packages that we need to set up for the Husky robot. So there is a Gazebo package, then description, control, navigation, simulator, all this stuff. Okay, so you can simply clone it and build it. Okay, and if you build it, if you are finding any dependency or something, you have to install it. So there is a Noitic Devel is available, meaning it is it will work well with Noitic. So first we can try with the binaries. Okay, so you don't need to worry about anything. Just click and install. Just a second. Okay. Seems like if you click the details, you can see it is installing. Okay. Yeah, it seems like it's installed. Okay. Now what you can do is, in order to start the simulation, the package name is Husky Gazebo, right? So just check whether the package is visible. Okay, so yes, it is installed and it is visible. So now just do ROS launch Husky Gazebo and then press the tab twice. Then you can see the existing launch files. So let me try with Husky empty world. Let's see whether it work or not. Okay, it is checking for joystick, but we don't have joystick anymore. Let's see whether the simulation will come or not. Yes. Okay, so this is our robot. Okay, now after checking it, just check for the error. So this error is for the PID, so it's not critical. This actually Husky can be controlled using joystick, the real joystick. I mean, the simulation can be controlled using real joystick, but we don't have that. So yeah, I think I have one, but yeah, let me. No, anyway, I can just leave it. Okay, so now the simulation is here. Okay, so now you can just check the topics. ROS topic, use ROS topic list, and then you can see a list of topics. Okay, the command velocity, I think you know about the command velocity. If you publish linear and angular velocity, the robot will move. Then we have velocity controller. Okay, that we will see. Then IMU, it is having an IMU sensor. Then it is having GPS. Okay, we can even add GPS to the simulation. Then odometry. So this is a sensor fused odometry, because normally we will get odometry only from the wheel encoders, right? But we can fuse the odometry with IMU, then camera, then laser odometry. All this stuff we can add. Okay, and there are some twist markers server, so we can actually control the robot in multiple ways. I can show you that. Fine, so I think you got an idea, right? So let me open RQT and let me close this plugin, and then I'm loading the steering plugin. Okay, steering plugin. So just push, I mean send the command velocity, and look at it. It's actually moving, right? It's actually moving. The robot is actually moving, right? And did we see any laser scan? I think it doesn't have any laser scan, but let me see the robot only. Let me see if it is having any laser scan. Okay. Oh, that's strange. Okay, I think it doesn't have any laser scan. Fine, anyway, we can just play with it. Okay, so if you just give the linear velocity, it will move forward, and if you give the angular velocity, it will like rotate. It is having 4 wheels, right? So it's very difficult to rotate actually. Yeah, you can see it is skidding sometime. Got it? And can we do the visualization? Okay, so let me do the visualization. So for the visualization also, I think there are some packages. So here there is a package called Husky Vis. Vis means visualization, mainly related to RVs. So if you just check this launch file, let me check what will happen. Yeah, it is launching RVs with some configuration. Okay, yes, and now yeah, yes, you can see the visualization. Let me try to control it. Interact. Yeah, so in Husky robot they are actually giving an additional node for controlling the robot from RVs. It's called twist marker. Okay, so if you just move using the twist, okay, the robot will also move in the actual real world or in the simulation. Okay, so here you can see the on the right side you can see the simulated robot, and this is a visualization. Okay, so just a sec. Okay, so this thing, no, this round thing, this is called twist marker or interactive marker. So if you want to move the robot, you can just change to interact button and then just pull this. Okay, so the robot will move according to the thing. Okay, so this is very helpful while moving the for interacting with the robot. Okay, it's actually a teleoperation. Okay, this is actually a teleoperation, but in a good way. Okay, interesting, right? Yeah, so yeah, so that is it. And we can also visualize IMU. Let me check whether it will work or not. Okay, IMUs. So when you move, yeah, IMU, you can see there is an arrow, right? That is actually showing the IMU. So if you rotate, the arrow will also rotate, something like that. Okay, so IMU is showing. Okay, so this is actually the Husky robot simulation, and I think there are some other example which is having the laser scan, so we can just play with the other launch file. Let me just try that as well. Let me close this. Okay, so instead of Husky empty world, I'm just launching playpen. Yeah, let me see whether it work or not. Okay, yeah, the thing is that it has to load a world. Okay, that's why it is taking some time. If the world is already there, then it will load very quickly. So there is a world called playpen. Let me see. Otherwise I need to copy that world into the .gazebo model folder. So let me do that. Just a second. I'm just closing this thing, and I'm just going to Husky Gazebo, and there is a thing called world folder, and here it is, the world file, which is an SDF file. So when we load this world, okay, it is actually trying to load some models, okay, like jersey barriers. Then yeah, it is actually this world. Now this world is loading with some models. Okay, so if that models are not available, then this will not work. Okay, so that is the logic. Yes. Okay, so let me see. It's available in our .gazebo folder. Just a second. Okay, so we have the Gazebo folder, and in models, okay, so in models, you know, there is no jersey barrier model. So, okay, so that's why it is not loading. So basically what we have to do is you have to go to Gazebo models GitHub. So there is a, I think I have shown to you this. This is a list of models from the official Gazebo repository. Okay, so this much of models are available. Okay, so what you can do is you can simply go to this this repository, and then just take this, just a second, and then download it. Download a zip, Okay, it will take some time. Just wait for some time. In the meantime, I can show you the Husky thing. Yeah, so this repository, this repository is having almost all the things for creating a robot simulation. Okay, so I am actually taking these kind of repository for a reference for creating our own simulation. Okay, so I don't know how many of you heard about the Husky robot, which is a very famous robot. I have worked with the actual hardware. So Husky is an outdoor robot, a very rugged robot from ClearPath Robotics. So ClearPath Robotics, the ClearPath Robotics is one of the company that is that started from the Willow Garage. Okay, Willow Garage is a company who started ROS. Okay, so the Willow Garage engineers actually started this company, and these company actually created Turtleboat 2, and they are actually doing a lot of things in ROS. So one of the rugged robot, this is a very successful robot. Anyway, it's available in India, but it's very costly, like 30 lakh or something. But it's very rugged. Okay, so you can add a lot of sensors. It's an outdoor robot, right? You can add lidar, then long range Wi-Fi, then industrial grade laser scanners, then GPS, a lot of sensors you can add. Okay, and you can mount even robotic arms. Okay, so how much, I mean, it's very big actually. Okay, so here is one photo with dual arm configuration. Okay, so there are a lot of work happening around Husky. Okay, yeah. Okay, so let me go back to, yeah, I think it will take some time. And now the next simulation I am going to show you is the Turtleboat 3, which is the famous educational robot. Okay, so for Turtleboat 3 also, we have the repository. If you just search for Turtleboat 3 GitHub, you will get the official packages. The same stuff, the description, navigation, bring up. Yeah, I think they are maintaining the simulation in a different repository. Let me check. Okay, Emmanuel. Okay, manipulator, Turtleboat 3 simulation. Okay, I think this package will work, but we need these two repository. Okay, so you can clone these two repository to the workspace. Otherwise, you can install it from the Synaptic Package Manager. Okay, I think Turtleboat 4 is there. That is the latest release of Turtleboat, which is I think, I don't know, like I didn't try the simulation of it, but let me try. Yeah, the repository is here. This is a new one, and also the manual, but it is only having the hardware related file and also the ROS2 files. Okay, so this is for the Galactic. So Galactic is a ROS2 version. Yeah, it's for the Galactic. Okay, and they have mentioned about how to configure nav2, which is the navigation stack for ROS2. All these stuffs are there. Okay, okay, so we will see that. And also for Turtleboat 3 as well, the ROS1 and ROS2 support is there. Okay, okay, so we have downloaded the models. So what you have to do is you have to extract or just open this model folder and then select it and extract to which folder? .gazebo models. Okay, .gazebo models. You can just extract. Okay, replace all. So now what we are doing is we are we are just extracting all the available models of Gazebo into your local system. Okay, otherwise what happening is that if you just try to load a world file or a model, what Gazebo does is that Gazebo will try to load these models from internet. Okay, so what happening is that it will take a lot of time, and then you have to wait. Okay, you have to wait. So that's what happened for the playpen. So now you can check what the speed of loading. So I will recommend you to download these models from the Git repository and copy to Gazebo /models folder. So now you can see the complete the world is here, and this robot also doesn't have the lidar. Okay, but for navigation we need, but maybe just simulation. Okay, so you can see all these models now. These this is the Jersey barrier, which is an official model from Gazebo, and all these models are official only. Okay, yeah, so this is the world of playpen, and now you can like interact with the robot using RQT. Just a second. Yeah, yeah, it is moving. I mean the same robot but in a different world. Okay, so if you want to check the simulation in different world, it's quite possible. Okay, it's actually hit an obstacle. Let me just increase the speed and let me see how what will happen. Yeah, it's in maximum speed, so you guys can see it's like yeah, maybe I can just reduce the linear velocity, sorry, angular velocity, and let's see. Yeah, so you can actually simulate a lot of scenarios in the simulation. Okay, but just imagine to work with this expensive hardware and simulate different conditions. That is not possible, right? So the simulation is for that. Working with the real hardware actually it's very risky. Okay, so if it is hitting on a actual Jersey barrier, then the robot can damage. I mean, it's a rugged robot, but some part can damage, and each part is very expensive. So you can simulate different kinds of scenarios in simulation, right? So that is the advantage of simulating this. Okay, yeah, so this is Husky robot. Okay, and what we can learn from this example is it's almost the same thing. Okay, but unfortunately they didn't add the laser scanner, so I didn't understand why they didn't add it. But let me just check the description package, URDF and Husky. So in order to find the main URDF file, you can check a sacro file with a name will be like the main URDF file. Okay, so now yeah, so in the URDF actually they have mentioned it, but somehow they are not using it. Okay, anyway, in the simulation, this is the description.launch, just loading. Yeah, so I think if you try the source code, it will have the laser scanner. Okay, but in the binaries it doesn't have. Got it. Okay, so you can just start it. Okay, yes. Okay, so that's it of about the Husky. Now we can jump into Turtleboard 3 simulation, which is a very popular one. What you can do is just take the Synaptic, search for Turtleboard 3. If you don't have enough time to do the simulation, Turtleboard 3. Installing binary is too quick. So it's already installed. So what you can do is just go to Noetic Turtleboard 3. Yeah, you can just install it, and it's already installed, and this symbol indicate you can upgrade it. Okay, upgrade to the latest version. So I'm just upgrading it. So you can find this a thing called dbg sim. So it is debug. It's for debugging. You don't need to install that. Okay. So just install these packages. Yes, I think it's ready to go. Okay, so now apply. So it will be updating with the latest packages of Turtleboard 3. Okay, let's wait for some time. So I think I have already shown you the Turtleboard 3 simulation. It's a very small robot. I will recommend it for learning purpose, educational, for taking ROS based workshop. I have one. I have Turtleboard 3 burger and waffle. Actually the company sent to me for testing, so I have the robot with me. Yeah, it's too small actually. I really like Turtleboard 2, and 4 is also good. It's actually having bigger size. Okay, so I have added it. Now the same thing, ROS CD, Turtleboard 3 Gazebo. Yes, so it is finding, the system is finding the packages. So now just start the simulation. So there are many launch files. Okay, so maybe I can launch some yeah, maybe auto race or something. Okay, we can see a racing environment. Okay, seems like that is not available. Then let me check if there is any other thing. Auto race. Oh, just a second. Just checking. Yeah. Yeah, it's loading. Yeah. Okay. So here is the Turtleboard 3. It's called Turtleboard 3 Burger. Okay. Okay, burger. I think why it is called burger, because there are different layers. Okay. And there is a waffle. It will look like a waffle, like a, yeah, I mean the shape. Okay, so here this world, now this world is for autonomous navigation, not autonomous navigation, autonomous racing. Like the robot should detect the lanes mainly, and then it will go through this road, okay, by detecting autonomously. So then it should reach the goal position. This is the goal position. In the meantime, like there are stop symbols, all these things. So this world can be used for computer vision related like challenges. Okay, so just give this world to someone and try to solve. It can be used for challenges, maybe in your college or like university you can use. Okay, yeah, so same thing, like if you do ROS topic list, you can able to see the topics, that is command velocity. Then there is a camera actually. Okay, so the camera can get back with the front view of the robot, so that can be used for line tracing. Just a second. So if you load the image and give the camera topic, you can see the lines. Okay, so this is the front view of the robot. Okay, so you can use this for training. Okay, you can use these images for training, and after that the robot can navigate autonomously. Okay, so if you move the robot, you can see the lanes are changing. and you have to rotate it. Okay, so this should done automatically, and that is only possible after training, some deep learning based training. Just I have done that one time using some yeah, with the same setup. Okay, okay, so it is having camera, then just a sec. Oh, yeah, this is a simulation. It's a camera, and there is a lidar, all this stuff. Okay, you can play with it. So just take ROS, just check what are the sensor data that we can visualize. Make the fixed frame as auto, okay, because it is providing the odometry, and add by topic. So we have laser scan, then add the robot model. Okay, so I think there is some problem with the laser scan and robot model. Okay, that need to check. Yeah, I think this simulation will be only having some configurations, but maybe I can load a different one, which is a very standard simulation world. I think you may have seen it. Let me load the popular world. I think if you take any ROS tutorial, you can able to see this. Just a sec. Okay. Okay. Yes, this one. Okay, so this is very popular world. So here what you can see is there are different table kind of thing. Okay, so the robot can go to each tables, and the robot is actually inside this shape. Okay, now if you want to like do navigation, I'm just showing the demo. We didn't discuss about navigation stack or something, but I'm just showing it. Just start the navigation, and just give a goal position, so the robot will autonomously move to that position. Okay, so that is a basic application of this simulation. I mean, mainly demonstrating the robot navigation. Okay, navigation will have, I mean, all the things like mapping, localization, path planning, all the stuff. Okay, so here you can see there is a predefined map already for this world. So if you give a goal position to the robot will create a path. There are two types of path: global path, global plan or global path, and local path. So the red is the global plan, and yellow is the local plan. Local plan is a section of the global plan. Okay, so if you give a goal position, then based on the map and the sensors, you can see there is a laser scan, which is actually the green in color, which is the main sensor for identifying the obstacle around the robot. Okay, so after obstacle avoidance, you can see it is finding the obstacle, and it is giving a layer around this obstacle. Okay, so to move smoothly, it is giving some inflation layer, and it is planning the path around the center of this obstacle. Okay, yeah, so we will discuss that. So this is one simulation you can try. Okay, yes, I think, yeah, that's for now. Maybe tomorrow we can get back with exam. Okay, and then we have to discuss some more stuff for the projects. Okay, so no need to cover these topics now, but maybe I can discuss this chapter. Okay, I need to take classes maybe tomorrow and Sunday because I am actually taking a break from Tuesday. So I will be discussing basics of autonomous mobile robot, the navigation stack, SLAM and all. Okay, I will give an introduction, and then we can start doing the projects. Okay, yes. Okay, so now is the time for Q&A. Any question, guys? Do you have any questions? Any questions regarding these examples, or any questions? Okay, so if you don't have any questions, I think we can conclude for today, and we can continue with the same topic, and we will be jumping into this one, autonomous mobile robot, from next class. Okay, so if you have any questions, please let me know in Discord. Okay, okay guys, thanks for joining. See you tomorrow. Bye. Good night.